Okay, so we saw the reaction mechanism. Now we're just going to, let's quickly go through those six. Now we are no longer showing the reaction mechanism in number one. We just show what happens. So what happens, we saw that in here we have the first reaction is the hydration of alkenes, right? We have the hydration of alkenes, and we need an acid catalyst here. Okay, and this, remember, when we say alcohol preparation, we are also saying alcohol formation. So alcohol formation reactions we are making. So basically, we had an alkene, C double bond, Cr, like this, and it is going to meet an alcohol, whatever your alcohol, it's going to meet water, sorry, and we need an acid catalyst, H plus. Okay, this could be H2SO4, right, or HCl. And then what are we going to get at the end of the day? We are going to get it as a CH. If you want, you could put it like C, then show that there is an H, right? We could put the H down here. And then this C, which is bonded to an R, will now have an OH, like that. So that's what's going to happen. So on one of the C's, we got an OH here. This guy, we got the OH. And on the other one, we got the H. So that's what's going to happen. Now we go to reaction number two. In reaction number two, we are going to have aldehydes and ketones. Okay, so let's say reduction of aldehydes, and ketones. Okay, so we say, in brackets, we say using NaBH4. Okay, that's the reducing agent which we are going to use, which is going to be sodium borohydride or sodium tetrahydroborate. So in here, what's going to happen is NaBH4, we have two reducing agents, which is NaBH4 and LiAlH4. These are our reducing agents. Now, this one is very specific. Sometimes you hear them say a soft reducing agent. It works on certain guys. It's picky. He works on aldehydes and ketones, okay? On aldehydes and ketones. So he's not rough enough. But this LiAlH4, well, he can work on carboxylic acids and esters, okay? And esters, and he can reduce them again to alcohols. Because basically, let me tell you what, all these guys together are called carbonyls, okay? These guys together are called carbonyls. They have a C double bond O. So if you have a C double bond O, you can be reduced to an alcohol. This C double bond O is going to be reduced to a COH, okay, instead of C double bond O. So these are all the aldehydes, ketones, carboxylic acids, esters have a C double bond O, so we call them carbonyls. Now, what basically they are going to do is they are going to be reduced, and we saw that LiAlH4 is for carboxylic acids and esters. Now, let's quickly go through it. So we start with aldehydes and ketones. Basically, in our aldehyde, whatever we have, remember that the aldehyde, the carbon double bond, this C double bond O, is on the last carbon for aldehyde. Okay, so you see an H and then R. So basically, whatever happens on the other side, we don't care. But we know that on the last carbon, that's where you're going to see the carbonyl functional group. So anyway, let's put something nice. Okay, I'm going to put something like this. And here is a hydrogen. So it's like this. Where is the last carbon? It is here. That's the terminal. Because look, we said carbons are there on corners and on the ends of line if there is nothing on that end. If you see here, there is a hydrogen on this end, so we can't put a carbon there. So this is just a carbon. So this is the last carbon, which is right here. Is the last one. And that's where the double bond O is. So this is an aldehyde. The reason we don't remove this H is to show you it's an aldehyde. Okay, so now, because there is a double bond O here, so this double bond O could not be on the last. We couldn't, how were we going to do it? To put our bond line formula and put a double bond O at the end. How are you going to do it? Okay, so we couldn't have done this and said something like this. No. So in here, we're going to have it like that. So anyway, what happens is this guy is going to meet up with, in reduction, is going to be reduced. We can just put it as an arrow, but in actual fact because instead of showing that as a reaction, we can just put it as an arrow to say NaBH4. That's what they actually do here. That's the first thing, and you're going to need it to be a little bit acidic, so you put an acid in water. But remember, this thing every time we are going to use this NaBH4, when we are reducing our aldehydes or ketones, we dissolve them in ethanol. So we need ethanol as our solvent, and we're going to put a little bit of acid. So at the end of the day, what are we going to then have? We are going to have this becoming an OH, basically. So we put our two mountains, and here it's now a single bond to an O, which is bonded to an H. And that's the end. That's what you only do, and you're done. Because you know that here, this carbon is now, again, you've added another hydrogen to him, but we never put those hydrogen bonds. So it's going to be like this. Remember to put your H at the end. It was an H. So here's your terminal carbon, and you're done. For ketone, what would you have? This aldehyde has 1, 2, 3, 4 carbons. So it's going to be but. You can write it as butanol, right? Because it's an aldehyde. Then what's going to happen here is we have again 1, 2, 3, 4. So it's going to be a but. So we can write it as butane 1O, or because the OH is on the first one, or we can write it as 1-butanol. Okay, we can write it as 1-butanol. Now let's go for ketone. For ketone, we have again, let's put it like this. Ketone, you have your double bond inside. It's not on the last carbon. Here's my last carbon. It's not there. So it could be here or it could be here. That's why we're going to have our ketone. Let's put it there. And if he again meets, we have our NaBH4, which is an ethanol. We have our ethanol as our solvent. This is the first thing we need. Then the second thing we need is a little bit of acid dissolved in water. What are we going to end up having? We have our ketone. What we're just going to end up is this O, double bond O becomes an OH. So basically, remember to make it a single bond, and it's now an OH, and you are done. That's all you need. Now, what is this going to be? This was how many things did we have? 1, 2, 3, 4, 5. So this was a pentanone. Okay, it was a pentanone, but this thing was on number 3, was on carbon number 3. So it's a 3-pentanone. Okay, ketones end with non, aldehydes end with now. Okay, so basically it's pentanone, and then what's going to, well, let's say they end with a now. These ones, they end with anon. Okay, that's better. Pent, then anon. Yeah, but, then anal. Okay, they end with anal, then anon. So basically what's going to happen is we have now on our ketone, we have reduced it to an alcohol. So this is still 1, 2, 3, 4, 5. So it's going to be pentanol, but we need to tell us where the carbon is. It's on the 3rd position, so it's 3-pentanol. That's how easy it is. Okay, and this is going to be your final thing, and you're done. That's what happens with these two guys. Now, for you to see the carboxylic acids, and we can put now on our thing, we've done a reduction of aldehydes and ketones. On 3 of the 6, it's now reduction. Okay, we can now say it is now reduction of carboxylic acids. Okay, carboxylic acids and esters. Okay, and esters. And who are we going to use? LiAlH4. Now let's quickly put it. Let's put 1 as an example. For acid, we start with something like this. And here we have our O. Now for acid, it will have an OH again at the end. That's what it is. So an acid is C double bond O, then can have it as an OH. Okay, so the carbon, the last carbon, it's the last carbon all the time. The last carbon is going to be bonded to the double bond O, but then again an OH. Okay, so what do we have? We are going to add it to, in here we are now using a harder, more reactive reducing agent, which is LiAlH4, because he's like, we need to put him in ether as our solvent, okay, to kind of calm him down a bit. He's he's the more reactive reducing agent. Reducing means we add hydrogen. So to add hydrogens is to reduce something. I hope you guys still remember that. So now what's going to happen is we are going to have this carboxylic acid, whatever it is. Okay, we can name it 1, 2, 3, 4. Okay, there's no carbon here because it's the end, but there is something. There's an OH, so we don't put it. So there are 4, so it's going to be butanoic acid. Okay, butanoic acid, easiest thing ever, because carboxylic acid end with anoic acid. Okay, but is for 4 carbons. Okay, so now this guy, what is it going to meet? This guy, we still put 2, we still put a little bit of acid, so H3O plus. Now what's going to happen is we are going to get, what changes here is, let me tell you something. This is what changes. This guy, we remove it, we put an H. Here, we break the double bond, we make it a single bond, O and an H. So that's what's going to happen. So let's quickly do it. So it's going to be first mountain, second mountain. In here, we remove the OH, we put an H. And in here, this double bond O becomes an OH. Okay, so that's going to happen. So basically what we did here is this OH is gone. And when this OH goes, he's going to meet an H plus, another H plus, and he's going to become a water. So here we actually put another guy to be released, and that's your water. And that's going to be what happens. So here, what do we now call this? It's an alcohol, right? And it's just going to be butanol, okay? Butanol. You can call it 1-butanol because it's on the first position, and water. Now, let's put our last thing, ester. What are we going to have as our ester? We're going to have something like this. Same thing. What just changes is instead of having an OH, you have an O. Instead of an H on an ester, instead of an H, we have it as a C something something, okay? So C then keeps going. So here, let's just say CH3, okay? Instead of an H. So the chain doesn't end yet. It's not the last carbon. So basically, what are we going to, what is the name given to this ester? Remember that the first part comes from this guy that is your methyl group. So he's going to be, since he's only alone, we call him a methyl. Then here we count 1, 2, 3, 4. What's going to happen is there are 4 things. Okay, so it's going to be but, and since he is the 4 guys, we call it a butanoate. Okay, methyl butanoate. Now what happens is he's going to meet, let's make him meet the LiAlH4. Don't be scared. It's an ester. Yes, we meet the LiAH4 we need in ether. Okay, and then here we have a little bit of the H3O. Okay, a little bit of acidic water. Then what are we going to have now? Same thing that happens, but remember what happens now is, remember what we did for carboxylic acid is, let me put it nicely. This double bond O becomes a single bond OH. Then this part is thrown away. So instead of having an OCH3, we remove it, we put an H. That's what happens. And now what happens is this OCH3 is going to meet an H, another H, and become a CH3OH, which is another alcohol. So what's going to happen at the end of the day is we are going to have this guy with 1, 2, 3, 4 carbons. So we'll call him butanol, and the OH is on the first carbon. Okay, if we are counting from the left, this is going to be the first, the second, the third, the fourth. We always count from where the thing is attached to, the closest end. So this is 1-butanol. Okay, and here we have another, which is methanol. Yay! So we are done, and that is it with these reduction guys. Okay, let's go ahead and let's see the last 2. We'll be done.